D is the variable that we use to represent the common difference. So the common difference for, let's say, 10, 12, 14, 16, this is an arithmetic sequence because we are adding a number every single time. And the common difference here would be 2, positive 2, because we're adding 2 every single time. An arithmetic sequence could also be a sequence of repeated subtraction. It just means that your common difference was negative. So maybe I started at 10 and my sequence is 10, 8, 6, 4, 2, 0, negative 2, negative 4, right? I'm getting smaller and smaller and smaller, but still by that same number being added every time. It's just negative 2 is being added every time, which looks and behaves like a subtraction, as opposed to positive 2 being added every single time, which would be a positive common difference. So my common difference is 2. And my u sub 1 is 10. This is important to know because we have a formula for arithmetic sequences that, that tells you what the nth term would be. As long as you know these two pieces of information, you can write the nth term of the sequence and you don't have to figure out what is the table of values and then how do I write that equation. The formula is found in your formula packet, so you don't have to have it memorized. It's the very first formula of new formulas in your formula packet, which is why a lot of teachers teach it first. The formula is u sub n, so the nth term of the sequence, the formula, the equation, is u sub 1 plus n minus 1 times d. U sub n is like your y, right? Looking at these guys right here, u sub n, it's like y equals, right? And then remember that n is kind of like your x, right? It's kind of like your input. And so you always, like with equations, you always need to have a y and an x in your equation, unless it's a horizontal or vertical line. But the general idea is you always have like a y and an x somewhere in there in your equation. For this guy, you always need to have a u sub n and an n in your nth term, in your formula for this sequence, in order for you to have an input and an output. So then the numbers that you need to plug in are, you need to plug in a number for u sub 1, and you need to plug in a number for d. And then you leave n and you leave u sub n, and you end up with an equation. So we're going to practice that real quick. Since we knew that our first term was 10, our common difference is 2. U sub n is equal to u sub 1, which is 10, plus, remember we keep n in there. It needs to stay in there or else it's not an equation, just like we can't take x out and not have x in an equation. And then d is 2. I'm going to simplify this out a little bit by first applying that 2 to both of those pieces. So we get u sub n equals 10 plus 2n minus 2. U sub n equals 2n, 10 minus 2 is 8. And that is your equation. These equations are a little bit harder to put together than these equations because with these equations, your first term is your common difference, right? It was 3, 6, 9, and it was a common difference of 3, a common difference of 2, started with 2, 4, 6. So we didn't have to have any plus situation. Whereas when you don't have your first term equal to your common difference, that pattern is harder to establish. If 1 goes to 10, 2 goes to 12, 3 goes to 14, 5 goes to 16, you might be a little bit like, I don't really know what I'm multiplying by in order to get here. And so that's why this formula here is really nice, is because then this is what your formula is. It's not like the puzzling out of looking at your table of values. Okay, arithmetic sequences. It's a sequence of numbers that follow a pattern, very specifically addition or subtraction, because we just know adding a negative number is repeated subtraction. Let's practice. The first term of an arithmetic sequence is 5, and its common difference is 2/3. Find the second and third terms of the sequence. Write out the information that you're given with respect to the variables that it needs to go with. If the first term is 5, write u sub 1 equals 5. If the common difference is 2/3, write 2/3, write 2/3 equals d. I have all of that information. So it says find the second and third terms. Well, the first term would be 5. The second term would be 5 plus 2/3. And then the third term would be that 5 plus 2/3 from our previous guy, and then plus another 2/3. So to simplify this down, 5 plus 2/3 as a simplified fraction, this would be 15 over 3, so then that would be 17 over 3. And then 17 over 3 plus 2 over 3 would be 19 over 3. See the fractions here? Remember above when I was like, yeah, fractions can be really hard because sometimes our denominators are simplified down. It's hard to tell what the pattern is. If this was then remade to be 15 over 3, then it would be easy to see that, oh, well, every single time in my denominator there's a 3, and then we add 2 every single time to a starting number of 15. And so you can always separate the pattern that's happening in the numerator separate from the pattern that's happening in the denominator to kind of make sense of what's going on with fractions. U sub 2 equals 17 over 3. U sub 3 equals 19 over 3. It then says write down an expression for the nth term. I want you to do this on your own. Remember, we just went through a whole process of practicing using this formula. So I would like for you to use that formula. Using the formula up above, U sub n equals U sub 1 is 5 plus n minus 1 times 2/3. I'm going to go ahead and distribute 2/3 to both terms, which results in 2/3 n. 5 minus 2/3, that would be 15/3, minus 2/3 would be 13/3. Okay, we are continuing with this situation because C and D are responsive to the previous page. It says determine whether or not 49/3 is a term of this sequence. The thing to keep in mind is that if n is the number of the term, we've got the first term, the second term, the third term, the fourth term, we'll never have something like a 1.3 term or the 5.6 term. We'll always have numbers that are integers for n. N will always exist in the integers. Remember, this fancy E means exists in, right? So the number will always be within the world of. And then this really fancy bolded Z means integers, just like the really fancy bolded R means real numbers, the fancy bolded Z means integers. So when it asks for, hey, is 49/3 a term of the sequence, we've just created an equation for this sequence. U sub n equals 2/3 n plus 13/3. Okay, so if we want to know if 49/3 is one of the terms, n is the term number, U sub n is the term. Right? And so if I put 49/3 in place of U sub n, like an output, 49/3 equals 2/3 n plus 13/3. I'm trying to say, hey, which term number would give me 49/3? Go ahead and solve for n and tell me, and then we'll talk about it. Just solve for n. You can use numerical solve. You can try and do this algebraically. If you want to do this algebraically, multiply everything by 3 would be a really nice thing to do first because it gets rid of all of your fractions, and then all you do is 2n plus 13 equals 49, or you can use numerical solve. The answer that we get is n equals 18. That means that the 18th term is 49/3. So this is a term in the sequence. If we got something like 18.5, if we got something like 5.6, then we would have to say no, because that doesn't exist in regards to this idea of the number of the term. So because we got an integer as our answer, we know that this 49 thirds is a term that's in the sequence. I just didn't want to list out all of my terms and get to the 18th term and be like, oh, hey, there's 49 thirds.